Today, we're going to take scientific notation one step further, and we're going to actually multiply and divide numbers in scientific notation, and then we're going to make sure that the answers are written in proper scientific notation. Scientific notation is a great way to write a number that is really big or really small, and multiplying and dividing those numbers in scientific notation is easier than if we leave them really big or really small in standard notation. So today we're definitely going to be thinking about why is it helpful to write numbers in different ways. It is considerably easier to multiply and divide these numbers that we're going to be working with in scientific notation. So the first thing we're going to actually talk about is fixing scientific notation. Sometimes at first glance, you'll look at a number and you'll say, oh yeah, that's in scientific notation. But on closer inspection, you're like, hey, wait a minute. The number out in front here is bigger than 10. And remember, we were only supposed to have one digit in front of the decimal, and this guy's got two. So even though this looks like it's in scientific notation, we have a problem. So the first thing we're going to do to fix it is we're going to put that decimal where it belongs. So here we would move that decimal one place, and as we move it one place, notice that the number is going from 34.5 to 3.45. A power of 10 is being removed. And when we make the number in front smaller by that power of 10, we need to compensate and go to the power of 10 at the end and put it back in, because we want to have the same value. So if we just take a power of 10 off, then it's a different number. It's a different value. So when you move that decimal here and one power of 10 is now been removed, you have to add it to the exponent. So the proper scientific notation would be 3.45 times 10 to the 7. But both these numbers are the same value. They're just, this one's written in proper scientific notation. I'm going to do 4 with you, and then I'm going to ask you to try yourself fixing scientific notation. So this one looks like it's in scientific notation. It has a number times the power of 10, but look, we got a problem up front, right? So the decimal is after the 5. It's the invisible decimal, and it should be in between the 2 and the 6. So we're going to need to move it around the 5. That's 1 power of 10, and around the 6, that's 2. And we're making the number smaller. We're taking kind of out those 2 powers of 10. So we need to come over to the end of the number and put them back in. So it would be 2.65 times 10 to the 9th. 7 plus 2 would be 9. Over here, where would the decimal go on this one? Did you say in between the 2 and the 1? So we're going to move it around the 2. But this time, as we're moving it, we're making this number bigger by a power of 10, which means that we need to compensate and do the opposite on the back of the number and take it out of the power of 10. 2.13 and 8 take away 1 would give us the 7. Now, I'm going to be honest, the next two are where people make more mistakes on fixing because of the negative exponent. We're going to look again, same thing. We need to have that decimal in between the 3 and the 2, and right now it's hiding at the back of the 32. When we move it around the 2, we've just made that number 3.2. We're making the number smaller, and we moved it one place. That's 1 power of 10. We went down 1 power of 10. So over here, we need to go up 1 power of 10. Negative 8 plus 1. This is where the mistake is made, guys. Everybody will put the 3.2, but be careful. The negative numbers go in the opposite direction on the number line than the positives. But just think of it, negative 8 plus 1. That is not negative 9. It's negative 7. And that sometimes takes a little bit of thought, but just check yourself in the calculator. Think the answer, check it in the calculator. When we get to number 4, man, we've got to move that decimal. Around the 0, that's 1. Around the 0, that's 2. Around the 8, that's 3. And when we did that, we made the number bigger. So when we come out here, we need to make the number smaller, and we moved it 3 places. So basically what you're doing is negative 10 take away 3. Think of what that is. Check it in the calculator, And did you get negative 13? That is how we fix scientific notation. So have a piece of paper and a pencil ready. I'm going to click to the next slide, and then I'm going to ask you to fix for yourself. And here they are. So could you please pause the video and come back when you're ready to check your answers. Okay, so on number 1, you made it smaller by 1, so this should be larger by 1. Here you made it smaller by 2. This should be larger by 2. Add 2. Did you get the negative 4 there? Not negative 8. We're going to make this one larger by 2. So make the power of 10 smaller by 2. We're going to make this larger by 1. Make this smaller by 1. Negative 7 minus 1. Think it. Did you get the negative 8? And that's what fixing scientific notation is like. The reason I did that right up front is because we're now going to talk about multiplying and dividing. And when you get your answer for multiplying and dividing, if it's in improper scientific notation, you need to fix it like we just did. So we're going to start with multiplying, and this is going to sound familiar. We kind of talked about this when we were multiplying powers. But basically, scientific notation, we're going to multiply 7.2 times 10 to the third, and we're going to multiply it by 1.6 times 10 to the fourth. Now remember that this is 4 things being multiplied. 7.2 times 10 to the third times 1.6 times 10 to the fourth. So it would be easier to commute, to switch the order of these two so that the 7.2 and the 1.6 are next to each other. And then the 2 powers of 10 are next to each other. So right here, 7.2 times 1.6, I'm picking up my calculator. And I'm going to multiply those, and I'm getting 11.52, and that will be the number in front of the multiplication in the answer of multiplying these two scientific notations. It's called the product. So the product, the final answer, will be 11.52 times. Now I'm going to talk about the powers of 10. Here's why we had to talk about multiplying powers. When you multiply common bases, you write the base and add the exponents. Do you remember that from our a couple sections ago, 1D, multiplying and dividing exponents? So you would end up with 11.52, multiplying the numbers in front, times 10 to the 7th, adding the exponents. Wait, look. See why we had to fix? This is not improper scientific notation. So we need to move that decimal around the 1. We're making the number in front smaller, right? A power of 10 left there. So we need to put it into the back of the number. And that's how we multiply numbers in scientific notation. Let me do another example with you. This one isn't in your book. So I'm going to multiply 1.3 times 10 to the 11th times 4 times 10 to the 2nd. And the first thing I'm going to do, you're going to see in blue, is I'm going to use the commutative property. And I'm going to switch and put the 4 over here and the 10 to the 11th over there. Now this can go right into the calculator. 1.3 times 4. I think I actually show you, the math here. If you didn't have a calculator, there's your 12. Hold the 1. 4. Add that 1. You would get 52. 1 place behind the decimal, so you move it. You might remember. But of course, I've allowed you to have the calculator. So 5.2 will be the number in front of our answer. And I'm really happy about that. Why am I happy? I don't have to fix it, okay? It's already in the right form. Now I'm going to go and look at the powers of 10. When I multiply powers of 10, I'm going to write that base and add the exponents, right? So I'm going to write the base and add the exponents. And that will be the second part of my product, of my answer to a multiplication problem. And then I just check it, is it improper? Is it proper scientific notation? And it is, and I'm done. So you don't always have to fix them. I guess that's the point. Okay, so here is your turn. Got it. Unfortunately, I didn't put the page number up here. Let me just see if we can find it. Somewhere around page 60, guys. If you could do the two got it's A and B, pause the video and come back and make sure your answers are in proper scientific notation. Okay, so you should have taken 8.4 times 2.5, written it down, and then common base, it would be 10, and add the exponents, which would give you 2 plus 6 or 8. So you would have kind of started here. Oh no, it's not in scientific notation. So I need to put that decimal in between the 2 and the 1. I need to wrap around the 1. It's getting smaller by a power of 10, and I need to compensate and put the power of 10 back in the exponent. The next one, I'm going to take the 2.63 times the 1.2 in the calculator times the common base of 10, and now I'm going to add 4 and negative 3. Didn't have to fix this one, did you? It would be 3.156 times 10 to the first. And oh, by the way, that one, if you write it, you're fine. But oftentimes mathematicians, remember, we're lazy, and we would make that the invisible one. So this would be 3.156 times 10. Same answer. So now we're going to flip our thinking into division. And then we're going to do a little bit of approximation, and that's it for today. So when you have a division problem, remember, we're going to use this as our division in higher math, not the line with the little dots, okay? So this is your division, and this is going to remind us of when we were talking about division of powers, where I talked about if there are numbers in front, you divide the numbers in front, and then the common base, you take the top exponent minus the bottom. So that's kind of what we're going to be talking about. But I just want you to notice how confusing it is, those darn scientists, for putting the X in here, because it kind of makes you feel like it's a variable. So, you know, scientific notation, you just really have to realize that that is the multiplication symbol. Like I said, it's the scientists that did it, guys. So I'm going to take the 1.44 that's in front and divide it by the 6 in the calculator. And when I do that, I'm seeing 0.24, which is the same thing as 0.24. That's going to be the front of my quotient. The answer of a division problem is called the quotient. So that's going to be the front times. Now, when I have a common base and I'm dividing, I take the top exponent minus the bottom. So remember when we did this, you write the common base and you take the top exponent minus the bottom. So basically, I'm going to have 0.24 times 10 to the third. Careful, careful, careful. Look, look, look. It's not in proper scientific notation. I'm going to wrap that decimal around the 2. And when I do that, the number in front's getting bigger. 1 power of 10. See it? We're going up a power of 10 here. So we need to compensate, go the opposite there. And there's your final quotient. Your final answer to a division problem would be 2.4 times 10 to the second. So I'm going to ask you to pause the video. These are not in the book, and try to do 3 and 4 yourself. Calculator is welcome. Remember to divide the numbers in front. Write it down. Write your common base. Put the X in. Write your common base, and then top exponent minus bottom, and check to make sure if you have to fix it. When you're all set, play the video, and we'll see how we're doing. All right, 7.2 divided by 3.6 is 2. Times 10 to the 7 minus 3 to the 4th. No fixing needed. 3.6 divided by 9 is 0.4 times 10 minus 3 would give you a 7. And now this one needs to be fixed. So we're going to wrap around the 4, That's making it bigger, so this needs to get smaller. And how are we doing so far? So here's an example of where this is used in the real world. But we're not going to be specific here. We're actually going to do an estimate. You can see that I'm circling that. So in 2010, the world population was about 6,860,000,000. The population of the United States was about 3 times 10 to the 8th. So one of those numbers is in standard form and one is scientific notation. And that's our first problem. It's like an apple and an orange. About how many times greater is the world population than the population of the United States? When you have a problem where there's a bigger thing, oh, by the way, the world population, and you're asking how many United States would basically fit in. So you have a bigger thing, you want to know how many smaller things fit in. That is a division problem. The bigger thing divided by the smaller thing. So the first thing we're going to do, though, is that I'm going to make this an easier number. So I'm just going to call it, it's really close to 7 billion. Do you understand what they did right here? That's estimating, making it a nicer number. And then we're going to change that to scientific notation. So we need a decimal in between the 7 and the 0, right? So 1, 2, 3, 4, 5, 6, 7, 8. It takes 9. And this is a really big number, so it would be 7 times 10 to the 9. That's the bigger thing. It goes on top of the division. The United States goes on the bottom. This is the bigger thing. How many of the smaller fit in? That's a division problem. 7 divided by 3 is about 2.3. And 9 minus 8 is 1. So if you were to multiply this just to have its standard form, it's about 23 times larger. So the world population is about 23 times larger than the population of the United States. So I'm going to ask you to do one more problem, and then I just want to show you some calculator stuff. So the surface area of Lake Superior, which is the largest of our Great Lakes, is 8 times 10 to the 4th square kilometers. The surface area of the smallest Great Lake, which is Lake Ontario, is 18,160 square kilometers. About, that means estimate, nice numbers. How many times as great is the area covered by Lake Superior than Lake Ontario? So I'm going to give you a clue. This number right here, make it a really nice number, easy. Change it to scientific notation. And then remember, we have a bigger thing and a smaller thing, and it's asking how many of those fit in. Pause the video. Let's see how you do in a minute. All right, so start with the easy numbers. So I would have made that 18,160, 20,000, which is 2 times 10 to the 4th. Look how easy this is. And now when I divide, 8 divided by 2, it'll give me 4 times 10 to the, what's 4 minus 4? 0 power. Anything to the 0 is 1, right? So that's 4 times 1. So Lake Superior is about 4 times bigger than Lake Ontario by square, the surface area, square kilometers. Okay, so I just want you to notice something about, I'm going to use the TI-30 calculator, but if you were to multiply really big numbers in that calculator, sometimes you'll see a weird output, and you might in the past have gone, what the heck is that? Guys, it's scientific notation. So if you were to multiply 540,000 by 7,800,000, the answer that shows up in the calculator would be 4.212. And down here is a minute little x, 10 times 10 to the 12. You are now smarter than you've been because that is scientific notation. The calculator is changing it to scientific notation. Now, there are other calculators, and I'm not sure which one you have, and sometimes scientific notation can look a little different. This is a graphing calculator, so I'm just using that one. And I took 0.17 to the 4th. This is how the graphing calculator shows it. So there's the number out in front, and that E is an abbreviation for times 10 and then to the -4th. So if you see an E on a calculator, that is also scientific notation. And I just wanted you to have that ability to understand that going forward. So today we talked about computing scientific notation, multiplying and dividing. We're not going to do adding and subtracting in 8th grade, just multiplying and dividing. And we talked about fixing scientific notation. Really starts to show us where some of this math we've been learning, power rule or, our multiplication rule, some of those exponent rules are used. So guys, I hope you have a great day, and it's time to practice.